And Pratik has informed me that he has uploaded the first edition, or he will be uploading the first edition of the book, and he's trying to get the second edition as well. So please refer LMS.
Did you or your friends bought it from the Manning.com or you bought it from Amazon?
I bought a Kindle version. I mean
Okay.
the ebook.
Okay. So any difference buying from Amazon versus?
No, it's the same.
Okay.
It should be same. I don't think the books will have any. Wherever you get the best deal, you should go for it.
Mm-hmm.
What's the alternative of Amazon? Someone said here.
Sorry.
That is
Like,
the Manning.com, MANNIG.com.
okay,
That is
okay,
their publisher website.
okay.
You're saying something in mute, Ravi?
No, I was just talking to someone here.
Okay.
I hope everyone is back. We can start now, right?
Sir, apparently I have one doubt. There is a live
Yeah.
reading option for that book, second edition. There is no
Ah,
PDF available right now. You can read it on the website with limited time.
okay.
It won't allow you
Yeah.
to read. They put a crypted letters, I think.
Okay. Like I didn't get the other
Yeah,
versions.
you won't get. I mean, they have kind of encrypted the to prevent privacy, piracy, and all that.
Okay, class. I would suggest maybe you all can research a bit and then try to see what's the best option. Get hold of the book. Book is worth investing. I would say definitely. Take my word for it. Meanwhile, the theoretical aspects of it. So one way is I would, as I have said earlier, right? Use the first edition, which Pratik will upload on LMS shortly, and then the second one. Sorry, so for the updated portions of the second one, refer the GitHub link which I shared with you. GitHub has chapter-wise codes for everything, so it will have the updated code with the TensorFlow.keras. Okay. Hope that makes sense.
Yeah, got it, Ravi.
Okay, we'll start now. It's around 20-25 minutes, right? So we'll anybody who wants to share the screen for this, the Gensim one. I'm sure in the last module you have worked with Spacey and Gensim, right? Any of these modules?
Guys, please respond.
We had more of NLTK and Spacey. Did not go deep into the
Okay, no
what is
worries.
inside. Like it was like a reuse code type.
Okay. Yeah, I just want to introduce some word vector features in Spacey and Gensim. And Spacey, as I've seen, as like really cool features. Even Gensim is a good one. You just quickly do it. Anybody who's volunteering for sharing the screen, except Nidhi and Amit, who have already done it.
I would like to do it, but I don't know, some issue with sharing the screen. I am doing it. It is projecting from my side, but I don't know why it is not projecting.
Okay, no problem. Let's see. Uh, who else would like to do it? Kaushik,
Please share your screen.
Kaushik, you can you do it, please?
Yeah, sure. I'll share this.
Thank you. The link which I've just shared. Yeah.
Yeah.
Thank you. So, quick introduction. So this I we just covered like just before the lunch, I think, the word embedding concept or word vector concept. Now there are several modules in Python which help you to do that. Gensim and Spacey are two of them, right? So Spacey has so word creating your word embedding, and you will see that in Keras as well. When you are dealing with text data, it makes sense to have an embedding layer at the top, where while training the model, it will create that embedding for you, which will be helpful for you to like increases the performance of the model embedding, right? So, and it has advantage compared to a one hot encoding which you have just now. So in IMDb just now we saw that we were doing one hot encoding, but that is not recommended usually. It's more of a like just like it's a outdated one right now. But what we typically do is it's recommended to use an embedding layer on top of your Keras layer, which will generate word embeddings. So before we do all that, we want to quickly see on what are some of the ways to generate word embeddings, right? So there are popular models available, pre-trained models for which can generate word vectors for you, or you can train your own. So for both Spacey and Gensim are useful. So Spacey has this very easy way to load pre-trained models, and the one which you are seeing here on the screen is called the it's a huge model. It's called N-Core WebMD. It has some 20,000 words with I mean, or word vectors for 20,000 words. Is it not?
Yes.
I think they have recently updated Spacey. That is why it might have become slightly obsolete. As in this way of downloading. Can you see if this line is working for you? Yeah.
Oh, this one is not working actually. It is showing some error.
Yeah. It's, I think, because the Spacey has changed. Can you go to the Spacey documentation? We can quickly check. And you can just okay, or you can just Google for this Encore WebMD thing, and it will give you the latest update. The Spacey Encore WebMD.
So that's how they have done it.
Okay, so I'm searching as well. We need to find the latest update. Anybody finds, because it's happened very recently, I think a few, maybe a month back or so, right? So So have a look at this. I just pasted in the chat. It has some examples of
No, you need to download this info.
yeah, I think you need to download it first. Yeah, let me yeah, download Encore WebMD or whatever. Yeah. Yeah, that line will help you download it.
Yeah, but it won't work here, I guess.
Can anybody is anybody able to make this work? Please help us out.
Reading something on the Stack Overflow. Give me 2 minutes, I'll confirm.
Sure. Something which has happened over, like, say, seeing a lot of it in the last couple of months because they have changed the version to some 3 or something.
Okay, it worked for me now, so I can share.
Yeah, sure.
So this is, they have given the MD, but I have installed this SM.
Okay.
And after that, this line is not required. So this works actually, Python -m.
Okay. So can you do the MD thing with it then also? Post that, you can go back to that site which I shared and we can use some of the sample commands there. Yeah. So you have already loaded, so
yeah,
that line is not required. Yeah.
So this is no, this one I did not execute.
Okay. Cool. So
Let me execute it again.
yeah, that's fine. No errors, right? Thank God. So they have just changed the way to access that model, I think.
Yes. Yeah. Earlier, actually, if we install Spacey and if we write that, it used to work, but now I have to download this part.
Correct. That's the change. Okay. So okay. So what you see here is yeah, that ndoc WebMD is actually a pre-trained model, right? And it can give you word vectors for everything, even document vector also, right? So what is a document vector? FYI. So words are vectors. Now a document is also represented as some kind of combinations of those words, right? So a document vector is like a collection of word vectors, right? And it's also very useful in deep learning. You can convert your text classification inputs to document vectors and then run your model on it, right? So So this is like a document vector, and it has around, I think, 300 dimensions. 300. So if you see a bunch of 300 or 200 numbers, I don't remember exactly what is the dimension, but yeah, that's the that's one. So it's a pre-trained model. Now, okay, can you go back to that page again?
No,
There are
if you see here, they are taking doc of 3. So this is the what is this? This doc of 3. So it will take this sum on.
yes. Okay, so no. So go back to that page. It has explained that in the documentation, in the comments, right? Get the word. So you are correct what you were saying, right? 0, 1, 2, 3. So doc3 vector is the word vector, and doc vector is the entire document vector. Okay.
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 Then
Yeah. So Gensim is another one. Gensim is slightly it was really popular like a few years back, but I'd still want to give you a flavor, right? So you need to download a pre-trained word to vec model with of a Google, which is trained on Wikipedia. So can you download it? You will need to download that model first. Yeah, local folder.
so this module, Gensim.
No, that is there that you need to install. The pre-trained word to vec model. Yeah, that model actually needs to be downloaded from the web, and they have given a link. Yeah,
This one.
this one. Just Google for that code name. No, yeah. Google for that file name, the .bin file which you have there in the code. Yeah. Okay, so it's giving you an Amazon AWS link. Can you try that?
This will not work.
Okay, no problems. Okay, no problem. So Gensim, let's train our custom word vectors. This was just about using a pre-trained model. That's not an issue. So can you go to that sheet again? It is showing you how to custom train word embeddings. So once you have a word embedding created, you can do these commands like similarity between two vectors, similarity between yeah, and most similar word to simple. So straightforward, simple, uncomplicated, and all that things, right? So go down, please. You have this custom training of word vectors. Yeah, custom word embeddings. So it is for the news group data set, right? So news group data set is which contains approximately 20,000 news articles on 20 different topics. So we will just quickly train a custom word training, and based on this, you can now I'll share with you the Amazon food data set. I'm sure, not sure if you're aware of it. It's a huge data set, but before that, we'll just quickly run this. Can you just run this news group data set?
This one preparing.
Yeah.
But data directory won't work.
So they're downloading news groups from somewhere already. Just see above that. Gensim already has 20 news group.
These newsgroups already still exist. I thought that they have disappeared.
But they are giving some loop from where loop they have done this text directory and Gensim. Gensim is not at all used somewhere. Should I download it?
Okay. Looks like okay. So let me share with you on a CSV file, right? We can do it on if 20 newsgroup data is not downloadable. Let's because see Keras it is available 20 newsgroup. Don't do it. It'll take time. Let me share with you link for doing custom word embedding. Okay, I'm sharing an old link here, but that and use this for the word2vec. Reason I am covering Gensim is it's one of the few modules which allows you to create your custom word embedding. Okay, so just try this. Just the Gensim portion and a CSV file. Let me share with you a CSV file for this. I think Amazon food data set. Amazon whole food. Oh, but you need to actually upload it on Google Colab, right?
Yeah.
No worries. I can give you another data set called topical chat. For some reason I don't have it. Hey Pratik, can I share this topical chat dataset with you?
Yes, sir. I will upload the same at LMS.
Yeah, sure. So this data I'm sharing is for input for the custom word2vec model by Gensim. Topical chat. Okay, Pratik, you would have got the file. Just check.
Okay, sir.
So meanwhile, I'm just sharing my screen before you start doing the Gensim word2vec on this. This is the topical chat file. We will create a word vector out of this particular column. Let it open the message column. Okay. So you can read it in a pandas data frame and then take this message column and then take and create word vectors out of it, right? Using the link which I just shared. That's a small exercise. And this is a largest data set around 1,88,000 rows here. So
So will it take time to upload it in Google Colab?
That's a question I'm just asking myself. It's 11 MB file. How much time will it take? Any ideas?
Also depends on the internet everyone have.
Yeah, it depends on the internet. I'm just saying 11 MB file wouldn't like maybe it takes like 5 minutes or something.
Yes, it won't take long.
Yeah. I mean, I have seen MB. I mean, files which are in MBs getting uploaded. So let's see. If somebody has a problem, we'll see if there's a workaround. But this chat is also available on the web. Topical chat dataset. Just you can download. Meanwhile, while Pratik is uploading.
Yes, sir, it's uploaded.
Thank you.
It's in,
Thank you. So all of you
in the
can
platform.
download it. Yeah, and I think Kaushik, you were saying, please, if you can kindly share again.
Yeah, I'll let me download it and then.
Yeah, sure. Take your time. Yeah, no worries.
Sir, one question.
Mm-hmm.
Uh, why do we, I mean, there are so many models available before this Spacey and now Gensim. So why do we use Spacey and why do we use Gensim? I mean, any very specific thing about it? I
So
mean,
you're correct. Spacey and Gensim are, especially Gensim, was very popular, but Gensim has this capability where you can custom train and find out or train your vectors, document and word vectors. So for folks who are having like learning an introductory deep learning course, I always prefer to have them give them a flavor of how you can custom train a word vector. But Spacey is not. Spacey is something which is really very good module in terms of the pre-trained models it has. Right, just the example of the WebMD model, right? And apart from that, Spacey has a lot of these functions which are used for NER, the named entity recognition, and other things as well. So that's why Spacey is still very popular. Gensim, I just wanted to give a flavor to everybody so that you know how the custom training is done for a word vector.
okay, and the link that you shared in that one, it is used for the pre-trained word embeddings. Uh,
Yeah,
pre-trained models,
so
right?
yeah, it was, but so for example, the pre-trained word embedding it is referring to, right, has been removed by Google. They are no longer hosting it because it's a huge. I mean, I don't know what's the reason for that, but it was trained on Google News dataset. So maybe some issue they have removed it. So I have just shared the latest link on the chat, the Kaggle link that is reading the data from a CSV file. So for that only I have shared this topical chat with Pratik. You can download the topical chat CSV file from LMS and then run the code given in the Kaggle link I have shared to create a word vector.
Okay, thank you.
Yeah, okay, no problems. So yeah, once we are ready, we can share the screen.
Yeah, I can share now.
Yeah, please share.
Yes, this is the data.
Okay, yeah, correct. So now can you just run the Gensim one, Gensim lines from the Kaggle link? Not this one, not this one. The other one which I've just shared on chat. This is actually, yeah. Yeah, it's from the third line, yeah, where you can change the name of the column to the one which you are reading. I think it's a message for you. Yeah. Yeah, let's run the next. So it's basically just take it, clean it. I think you need to install Gensim.
Yeah, let me see whether it has it. I have it, but it says
Okay.
that size is not working.
No, so this is again a mismatch between various modules. Okay, so okay, so I think most likely this is a updation issue again. Just give me 1 second. Go to Gensim. We will see the Gensim documentation. 6th May 2022. So this is.
So if I remove the size, it worked, but I'm not sure what is the impact.
No, I'm just. It's instead of size, can you use what was the size value earlier?
100.
Use vector underscore size. So I just found the latest Gensim documentation. Sorry for saying so many links, but it's actually the issue is the apart from the documentation, nowhere else people update the old code.
Vector size, yeah, it worked with vector size, yeah.
Yeah, vector size. So I just found it in. So Radim Hurek is the guy who created Gensim, and he maintains this whole thing. So I just checked on his website, and
yeah, it worked now.
yeah. I hope everybody is trying to do this. Some struggles initially because of updation in models and modules. Took very little time actually. Why? Because you just took 5,000 sentences, right? Can you make it the entire 188,000? Let's see what kind of vector we get. Not here, at the top where you're reading the data set. Not here. Sorry. This is vector size. This is not your data size. So
Yeah,
you,
no,
yeah,
it is okay.
this one, right? This one I think you have, yeah. So this one, yeah. If you can, okay. There is some issue in the data set. Okay, can you do a?
Instead of that, can I make it 20,000 and try?
Yeah, maybe try 20,000. Yeah, because there is some special character in between which is causing an issue. Yeah,
I
20,124 is the one where you have the problem. Yeah, no, 20,124. So yeah, do whatever 20,000. You want to just skip it something. Yeah, okay, that's fine. 20,000 is fine. Yeah, and now you. Yeah, there are some vector similarity commands you can run it. So as you can see, this is extremely easy to create your own word vector. But now, as we will see in the forthcoming sessions, with the transformers, this has completely changed. And you can now on the fly generate these word vectors, of course, but this still is so for example, a couple of years back, I trained on the entire English Wikipedia doc to vec and a word to vec model, right? And it took around 2 days to train it on a powerful machine, but that model is still surprisingly helpful if you are looking at a project where you have to compare things. It is really powerful. Model trained on English Wikipedia. Okay, so yeah, you internet, that is fine. You can change to your data set, maybe cat or whatever is, or most similar. Yeah, vectors most similar. Just put any word and see if it is giving you proper, say cat or something. Ah, why co-author? I'm not sure what's the relationship between cat and co-author.
Speed walking, huge.
Yeah, so if you see results which are poor quality, it tells you that your number of epochs and your data size was not sufficient. So these were very small sentences, right, from chat, and we just took 20,000. So it is giving an error. It's giving like low quality. Try something else, maybe chat, the word chat itself instead of cat. No, in the last, the one which you just ran, chat. Hmm.
Yeah, it is coming. Chatting is 95%.
Chatting is fine. Yeah, okay. Yeah,
Thanks.
but thanks and night are not that great, but yeah. So
So this vectors, it will try to map with this training data, right? From this messages only.
correct. So the slide which I showed you, like each vector, each word is represented by its neighbors, right? So if your word chat had similar neighbors as chatting, right? So that is how it kind of gave you that score. So each word is surrounded by other words, and that's how its vector presentation is created. Those numbers which you see at the top,
Mhm.
right? Now for words which occur in the same context, it will be same, and that's why your closeness will be greater.
Yeah. That's it.
Okay, thank you for your support, Kaushik here. That's so. I wanted to give you a exercise on whatever we have covered till today, right? I'm just thinking what kind of exercise we can have.
Hey Kaushik, hope this code will be shared. My this thing, the data is still loading only.
Okay. Kaushik,
Okay.
please pass it on to either Pratik or you can share it here on the chat if it's allowing you to upload.
Yeah, sure. I'll share it.
I want to use this time to kind of go through some of the ways in which you can use Keras to create a model. So I will share my screen now. And I would, okay. And what is the page I'm referring is again from the Keras book, right? And working with Keras chapter, in fact. So have a look at this. Okay. And let me share the screen. Yeah. Tensor. So this was done for TensorFlow 2.6. Uh, so different. One of the things which you would see when you see a lot of these Keras codes is there are certain differences in which people create model. We saw some code today, right? But what are some typical ways of doing it? Let's understand, and what are the benefits as well, right? So there is this sequential class, which most of your models will be a type of, except maybe some of the machine vision ones, which will come later too, right? So from TensorFlow import Keras, TensorFlow Keras import layers, right? These two things you import, and then you do a keras.sequential and then you define the layers as well as the activation. So here you have just one input layer, right? And then you have output layer with this with 10 outputs and activation of softmax. or you can incrementally build a sequential model, right? This is you made it by keeping it as part of a sequential class here, okay? So you define it as these values, okay? Or you can add it by writing separate lines in as a code here, as a bunch of code. You define instantiate this. This is the most common ways you see it. If you remember today, the initial example we saw was like this only. You define a model object of keras.sequential type, and then you add these layers individually to it. Model.add layers dense activation value, then model.add layers dense 10 output activation softmax, right? That is one way. And then, or you can call a model to build. Okay, I can actually run this because it's on collab, right? Let's do that. Sure, why it is taking time, I think. Do I have to install something? Yeah, it.
Sir, which way you prefer?
Okay, my choice is this guy. I am so used to it. But I will tell you there are some benefits for this one. When you create a really complex model, which is like a combination of different kinds of. So you have a model like this. Okay, I need to open the slides once. Just 1 second.
I think the way we change the model in that one, you can just simply comment it, but it's a functional way. Then we
Hmm.
will have difficulty in changing the whole code, right?
Uh, the good point there. One, I wanted to show you one benefit of function, right, by a diagram. That's why I opened the slide. So
Okay.
let me take the pen, right? So see, straightforward case is this: the model has similar inputs, and it just flows in this direction, right? So it doesn't
Yeah.
matter if you do it a functional, but imagine a scenario, and I mean, I'm sure many of you would do such kind of problem where you have text input on one side and maybe a image input on the other side, right? Now text input
Mhm.
requires its own kind of model here, like maybe an LSTM, and
Yeah.
image requires a CNN on this side. So maybe, so the way CNN works, and I'm just jumping the gun, CNN will take this, extract features out of it, and at the last, at the end point, it will simply just make it a straight line of numbers, right? So now this guy and this guy can meet and combine in a last layer here, right? So you extracted feature out of an image, you extracted feature out of a text, and then you combined it to generate something, right? Maybe you are doing a model which says, is this text description related to the image, right? Maybe that's the problem you have. Just saying, okay?
Mhm.
And your answer is a yes or no, right? So in that case, defining this in a line by line thing will become really difficult to understand when you write in code. But when you're writing a functional code, you can separate these two things out, and then just call in the end, you can call them one by one, saying, okay, this last layer has one input coming from the text side, one input coming from the image side. Okay, so well, while you're doing really advanced and complex kind of I would not say complex, because again, it's not difficult to understand these. When once you understand how to do text classification and image classification, you can combine both of these, right? Then functional API, functional way of writing this is kind of preferred. That's what best practice. Again, best practices say that. Okay. Hope I was able to
Okay.
put my point. Yeah.
So
No, I get it.
one question I have. So till
Yeah. Yeah.
now, in all the code examples, we are seeing sequential model building only. Now,
Correct. Correct.
whatever you just explained, can it be done? Is there something like non-sequential or just a parallel kind of thing which you showed?
Uh, yes. Yes. we will see. This is today was the introduction to the deep learning in general, right? So we have not immediately jumped into it, but while doing NLP and the machine vision portions, we will definitely have use cases, right? Again, we will not walk through it in the class, but I can probably give a group project on such a model where you can combine two different kind of data. It is also called multimodal machine learning, right? There are different kinds of data you are using. Different the data set type is different, right? So you can probably, I can think of a project and give it to you as a group project, the class.
Okay.
Okay, please let's keep this in mind for that time.
I was looking
Yes.
forward towards model stacking. So
Yeah.
interesting.
Yeah. Model stacking is definitely interesting. And again, so something like a model stacking would only happen when you have like a problem, like a real life problem, which requires you to, I mean, where a simple arrangement is not just working out for you, right? So that's one thing. So you have a scenario in mind where you want to use model stacking.
I have in mind, but then okay, so this was regarding everyone has heard about autonomous cars.
Hmm.
So
Yeah.
there that the vision and the action, these two things.
Okay. So definitely inside autonomous vehicles machine learning ecosystem, I think the action which the driver is doing, right, or somebody on the pedestrian side is doing, I think again they are converting it into a signal which is being fed to the model somehow, right? So action on the steering would definitely be go as an electrical signal. Action on the pedestrian side would be mostly a machine vision kind of comparison, as not comparison. Machine vision would convert that into a signal which is fed to the model as well, input. But yeah, it autonomous cars are definitely kind of models which are definitely require a lot of these combined inputs for sure to work, right? So it's an interesting use case. I was recently seeing one of the I will just try to find out the link, share the link with you all. Is one, I think one of the online universities has started one autonomous vehicle course as well. Are you aware of that? So it
Audacity.
will, I think so. Audacity,
Yeah.
maybe
It is
Audacity.
actually the founder of Audacity is actually he was leading some projects in Google, and he started this on reinforcement learning actually, and then he demoed it on an empty. I mean, it was in California where he was demoing it. So I have seen that his demo, the recordings of.
Mm. Yeah. So okay. So even Coursera has self-driving car specialization. Okay, and I don't know what it requires. I definitely so yeah, this course is a will cover I mean, you will be equipped as a prerequisite here because it requires object detection, localization, again behavior. Okay, no, this is to actually. So what is the expectation?
Yeah, I can recognize the name of the people here in this. So the same thing they are
Okay,
talking about.
okay. Let's see on what is the courses terminology. Okay, state estimation and localization. Yeah, so see, it is teaching you about sensors. Develop a model of typical vehicle localization sensors, including GPUs and IMUs. Visual perception. So I think from 3 onwards and some aspects of course 2, your machine vision thing, which you'll cover in this course, will start preparing you for this. Okay, but to be honest, this course has a lot of other items which are specific to self-driving. So interesting one. People who are interested can try this. But machine vision portion, definitely we will be touching upon it. Maybe not specifically for autonomous driving, but object detection and semantic segmentation, we'll be doing it. Okay, any other questions before we come back to this? By the way, one example of a complex model is when you are giving a label to a image, right? The example which I showed in the slide earlier, that can be implemented using a complex model as well. I can share with you a link where you have that worked out. Have a look at how they have created that Keras model. Okay. So model.weights is just what are the weights initially for your model, whatever you have created, right? You'll have all these things. Somebody is asking a question. Okay. So again, a useful thing in Keras is model.summary, right? So it basically summarizes what kind of model you have, what kind of layer you have, dense, which is fully connected, and what is the output shape. So you have 64 outputs. The number of parameters is 256. You have 10 outputs. Number of parameters is 260. Sorry, 650. So total parameters is this plus this, and trainable parameters is this plus this. Difference between these two is there sometimes when you freeze some of the parameters for training, which you do in machine vision, where you sometimes use a very strong pre-trained model available, and you don't want to touch them because they have already learned something very important, and you just want to custom train the rest of the parameters. Then in that case, this number and trainable parameters will differ. We will see that in the machine vision course as one of the techniques to classify images. You can also do a model keras.sequential. You can name the models and layers, which I don't find really useful, but just in case you want to do a kind of when you're writing a very complex code and you want to refer the layers. My first layer, specifying the input shape of your model in advance. Again, one of the ways to do it is 3 comma this thing. You don't care about the second dimension. Model.summary tens 4, okay, done 64. Sorry, any? Okay, so if you can go on mute, please. Yeah. So yeah, model.summary again, and then you added one more layer here. So it kind of just shows you the output as well. Now that was the, I mean, the traditional way or the established way or more common way of writing the models. Let's look at the functional API. Simple example. Before let's run it and then try to understand it. So input is shape is 3, name is my input, features is layers dot dense 64 activation value inputs. So you see the difference. It is writing in this format. This layer's name is features, and it is having this as its properties. It's a dense layer with a 64 output and activation function of ReLU, and it is linked to inputs, and inputs is this much, right? Or inputs is described by this. Output is layers.dense 10, again activation softmax, and it is coming from features, right? So basically, so input is I. I think, is there a whiteboard in Teams?
Yes, it is there.
I'm just
When you do the screen share, you'll get that option.
Okay, I am screen sharing. Acha,
Yeah, meaning
if I do, okay, yeah, I got it. So if when I press on screen share, it will show me whiteboard as well. Okay, yeah, Microsoft Whiteboard. Hope you can see it. Is it coming up for you guys?
Yes.
Brilliant. Okay, so
I'm yet to see a screen share or a whiteboard.
I'm presenting whiteboard. Hope you see it.
Yes, it's coming.
So I just pasted the code which was there in that Jupyter notebook or Collab notebook. Okay. And I just wanted to draw another note here with maybe so input. Okay, I can type it actually. Yeah. So input I followed by features F, then followed by output. Okay. So that's how the syntax looks for a API kind of or the functional API way of defining a Keras model. Okay. So input is shape is 3 and the second dimension we don't care about. Name is my input. Features is whatever it's coming from inputs as the next layer of input, and its output is 64 and its activation is ReLU and so on, right? So that's one way defining it. Now going back to screen. So I think earlier there was some question on why we changed the input or the type of data set we were feeding while training to float 32, right? So you have an answer there by default. It is taking a data type to input as float 32. So that was the reason earlier. Again, I think it's basically he's showing it separately. None 64. Yeah. Yeah, let's see the summary. Okay. Multi-input, multi-output model. So let's look at a slightly complex example here, right? So vocabulary size 10,000. Now, by the way, are you seeing my screen?
Yeah, yeah. Ravi, just
Okay.
one question.
Yeah, sure. Going back.
He has to see those four lines where we are saying input, features, output. How we are defining those numbers? Like how it is, shape is fine. 3 by 1,
Yeah.
is it?
Yeah.
So
Three by
how?
three by three by doesn't matter. That's how you read it. So any dimension.
Hmm.
So you're just specifying the input is 3. This is the first dimension of my input. Okay.
Okay, and 64 here in the sense what?
Yeah. 64. Can I show it on the not whiteboard? It takes a lot of time. I'll go to the slide again and I'll show you. 64 means whatever is coming out of that layer, it will be 64. Okay, so no, not laser pointer. I need a pen. Sorry. So first layer had three inputs. Okay, and this next guy, and assuming these 3 inputs came to this guy, and it has 64 as an output number, right? So basically, what this means is there are 64 nodes in this layer which are going out. Okay, so it is basically taking your 3 inputs and then doing mathematical transformations in each of these nodes, and then in the next layer everything will go like 64 times, right? So this 64 means 64 such nodes in the next layer. Does it make sense? And then in the last says tens, right? 10, right? So which means you have to predict 10 categories. So it will have these 10 nodes, right? Or you can simplify it by showing this one big thing with 10 outputs. So 3 inputs transformed by 64 nodes in one layer, and in the next layer these transformed inputs are then again transformed to give an output in the last 10 as last 10 units, right? Or I would not say units, as 10 nodes, right? Where these 10 nodes are what you're trying to predict, right? So based on the problem and the type of classification or you need to do, or the type of regression you need to do, this last layer will be defined, right? So in the house pricing data set, we had this as 1 because we just needed to predict one number. We didn't need to predict 10 categories. But here we need to predict 10 categories. So we have 10. And that 64 means the output from that layer is 64 of these. Does this make sense?
No, so the output of this 64 layer of this means I still
Means nodes, these nodes.
yeah, 64.
Okay.
So
Yeah.
how do we get? So this is, if I'm not wrong, this
Mhm.
is some layers, like this is
Yes,
one layer.
yeah. So this is like okay, I have that slide here only, right? So yeah, so this is the input layer, right? And if you say 64, then this next layer instead of 3 has 64 of these circles, and the
Hmm.
last layer instead of 2 has 10 of these circles. That is what
Hmm.
you mean.
Yeah.
And it's a dense layer, which means each one of these circles is connected to each one of the next circles as well. Okay.
And
And so yeah, go ahead.
this number, the 64, like my question was very specific. Like how is it something I can give, or it is like I need to calculate or find or figure out?
Yeah, it's best practices again, I would say. And you would think, why am I saying everything is the same answer? But you will see that typically it's a power of 2, right?
Hmm.
It's you will not see a number like 19 there. Nobody uses 19 or 13. You use typically a power of 2, right? 64 is a power of 2, 16 is a power of 2, 64 is a power of 2, right?
Hmm.
So so to answer your question, it is usually the power of 2, and it also depends on the complexity of your problem. If you are predicting say 10 classes, right? So just now we were talking about the news data set, right? What is that called? Whatever, the news data set, which has 20 classes, right? So predicting 20 classes, if you put one of the hidden layers as just 8 classes, your model will not perform well because you are not allowing it to learn that very well, right? It needs some amount of complexity, the because the output requires at least 20 classes, and in between you are giving just 8 classes. Okay, so that's the problem. Not 8 classes, sorry, I'm saying just 8 layers to learn it. So that's the issue. Okay.
Okay, so that one thing it is understood that hidden layers number should be more, so that learning will be
Yeah,
uh,
learning that representation you learn should be sufficiently deep, sufficiently complex. So
correct.
what is the relationship here? If this is W1 weight, this is W2 weight. So every time this was like just 3 nodes. Now
Hmm.
you have your equation is including 64 nodes. So what W1 to W64, right? Now that's what gives you this complex, very complex equation, right? Now if you decide to reduce the number of nodes, this number of equations would go down. Okay, sorry, the number of the complexity of this equation will go down, and your relationship which you learn will not be rich enough, right? It is needs to be a very rich relationship. Needs to learn those hidden connections between input and output that can only happen when you have a sufficient number of nodes. So that problem which you just raised can happen if you just take like 2 nodes and you try to predict a very complex problem, like maybe a 46 classes of output. So definitely when you do that, I will make it a point. I usually do it when I'm showing a example of maybe a text example. I will make you change, and you can do it for yourself as well, right? Don't wait for me to do that. You can change the number of layers, intermediate layers, and see how your accuracy goes down. Okay, just convince yourself. Your accuracy will go down because you are not making it sufficiently complex to learn those or pick up those deep relationship between the input and the output. Okay. Hope I'm
Okay.
making sense. Yeah.
Yeah. Thank you, Ravi.
Yeah. But great question, by the way. I really like that you are understanding or you're asking the exact question here on why the number of layers is 64 and number of layers is 10. Because it's kind of again best practices, but some of the best practices are that you should never have lesser number of layers or like the size of the layer rather than the output which you have, right? And once you start uh, running these typical models, you will automatically start thinking in terms of, okay, this is the first layer. I'll probably go with a 32, then followed by another 64. Then I will reduce it to maybe a couple of 32s again. And then in the end, I will do a 10 or 5 or whatever the number of output is there. So that's the whole idea. Okay. So this is an example of a multi-input, multi-output functional model. Vocabulary size 10,000, number of tags 100, number of departments 4. Not sure which. I hope they have a problem defined as well. Let's see if we can understand. So okay, so it is feeding a vocabulary size as an input. Name is the title of the body, or name is title of the book or something, right? Text body is shape of vocabulary size. Name is the text body. Okay. And so there are two inputs here. So that's why it's a multi-input. So it is taking the title and the text body as input. Tags is keras.input again, number of tags. So and name is tags. Features is layers.concatenate, title, text body, tags. Okay. Features layers then 64. Okay, so it is basically feeding a title, text body, and tags to a features layer with a 64 output. And priority is the output here with just one node, sigmoid activation priority features, which is taking these features. So as you read this, the picture should come in your mind that the output, final output layer is priority, which is taking and which has before that an intermediate layer of 64 nodes, and all these 60, and this layer is getting a input of this title, text body, and tags, right? So and department layer, number of departments, activation, say, and department features. Okay, so priority and number of departments are both being fed from features. And keras.model inputs is titled. So you see why it is called a multi-input, multi-output functional model, because there are three inputs here: title, text body, and tags, and output is priority and the department. I think we'll have to refer to the book for the actual problem statement. Let us just run it once. Mean squared error, categorical cross entropy. Okay, based on the title data you have. Okay, let's pick this up for a detailed discussion in the next class. It is actually an interesting one where you have different loss functions based on the different inputs, right? But I think Krishna Kumar has had that question, right? On he wants to do complex models. So this is one again, not a really complex, but an typical example where you have different kinds of inputs and different kinds of outputs as well. So that's where the power of uh, functional API of declaration comes in, right? This kind of definition. I mean, declaring this with a traditional way of, I mean, sequentially writing it would make it very complex. But in this case, you can just specify things like inputs are these three and outputs are these two. Sorry, I changed it. Yeah, and it makes your job very easy.
The last line works same for both of the ways. I mean, creating a final model to train, to fit, I mean, is same for both.
Okay, I thought you're talking about this last line. Okay, you're talking about this last line, huh? Model.compile and model.fit. Okay. Yeah. This is this is same because a model.fit basically tells that everything is ready. Just run the model
No,
and get me the output. Yeah.
Ravi sir, a line above model.compile
Uh-huh.
where model equals to keras.model. You see that line?
Okay, this one?
Just a line
Yeah.
above model.compile. Yeah.
This one? Yeah.
Yeah, this one correct. So keras.model equals input,
Uh-huh.
and then this title text body, even if I define either by a sequential or by functional, doesn't matter. Similarly, the output model, I mean, whatever way I have designed, changed it. But this model is the final one. So all of the ways it has to land in this way only.
Okay, so what is your point here? Can you clarify, please?
No, I am saying that this line will be common. I mean, whatever way we go, but from this line onwards, it will be common.
Acha, so I understand. So you are saying that what I just said is not correct. Yeah, and so what is the way you define it? Please tell me.
No, I mean, just before this last line of model, I mean, I can go
Mm-hmm.
either the sequential way or the functional way, but from
Mm-hmm.
this line where I define the final model,
Mm-hmm.
it's same for both of them. That's it.
Okay. So what did I say in that case? Can you help me understand what was my mistake, which you pointed out just now?
No, it was no mistake.
Then what was the point of your question? I did not understand.
No, it's not my question. I said that we start with a functional way or we start
Mm-hmm.
with a sequential way. I
Mm-hmm.
mean, by chaining it. But
Uh-huh.
just before fitting, when we define the last model object, so
Mm-hmm.
that line from that line onwards, it's one and same for all.
Okay, so then where is the difference lying in, right? So are you saying that this
The
same
difference
line,
on,
which is
yeah,
here, yeah, okay, and if you go to this one, uh, yeah, where do you see that input and output line here?
okay. So just before,
So you got my point, right? In this one, you don't see
I
that.
got your point.
Yeah. Okay. So yeah,
No,
when you
No,
asked
no,
that
I
question,
got
I
your
got
point. See,
confused. I got confused that are you saying that this is present in both? So that is why I was confused as to where did you see this? Okay.
so, sir, just one question. Like here
Yeah.
in the features, like the fourth line where we are defining features and layer
Mm-hmm.
concatenate title text tags.
Uh-huh.
Now we had three inputs and we gave it to the features layer, all three to features layer, right?
Yes.
So this is also same as dense, isn't it? Or like, for example, if we were not giving one of the input, like if we had removed tags, then probably we can say that all nodes are not connected. It is not dense. But is it same as dense or is it not same as dense?
Mm, no, I mean, I need to
No, no.
clarify
So
what yeah.
yeah.
So if
So
I
just
okay, just to help you, let me do a model dot summary. Okay. I
hmm,
hope that makes both of our life easier by clarifying. Okay.
mhm. Okay. So in some time back, like five, I don't know when, but we defined that a dense layer is when all
Yeah,
the
it is
nodes of previous
completely
layer.
it's completely connected. Yeah.
Yeah. So here in this case also because we are connecting three inputs,
Mm-hmm.
it is a dense layer basically because all the
Yeah.
three are connected, right? So,
Mm-hmm.
what is the difference in using this function earlier we defined for the feature versus just using the dense?
Okay.
Can you scroll a little bit up?
Yeah.
Yeah, here. So we are using two types of things. So first, the first line is layers dot concatenate, right? And then second is layers dot dense. So
Yeah.
so so will it create a different kind of output if we would have used dense there instead of explicitly connecting all three through concatenate?
Yeah. Yeah. If see, I get your question. I mean, I hope I get your question, but layers done concatenate is playing a different role here. It is
Mhm.
just saying that these three are my inputs, right? And it's you need to concatenate the input which you get from these three layers, okay? And
Okay.
then these three concatenated inputs will be passed through this dense layer of 64 nodes, is what it means. Okay. So
Hmm.
this concatenation is nothing but it is telling that the next layer which will have inputs from me, please treat all these three inputs as concatenated and then process I mean move to the next layer after that. So that's the difference between concatenate. These three will not connect to each other through dense layers because they are three separate inputs. And we are telling with the word concatenate that the next layer will receive the concatenated input from these three. And then only the next processing will happen. That's the
Okay.
difference between concatenate and dense.
Okay.
Any other questions? Okay, let's touch upon this in more details. Okay, I think this is okay. This is the I think the diagrammatical or visual representation of this input and output in this case, right? As I said, we should have this ticket classifier problem statement with us. We'll pick this up probably in the next class. Okay, and shape or the shape is also being saved here, right? Or shown here. So yeah, that's an example, the benefit of a functional API where this thing is even possible, where you have multiple inputs and multiple outputs. It can only be done with the functional API. Any other questions?
Guys, please ask if there is any other questions.
Uh, I need to ask for one concept, but it can be off record. I mean, and,
No, no, please be on record. I think it's fine. I don't have anything else to cover for the day, so it's fine with on the
I
record as well. Yeah.
I I want to understand what it means by padding.
Okay. So the way Keras works is it is not able to handle different size of inputs. Okay. So if I give it, so I think in the morning, the first time you asked the question, you had a Twitter disaster Twitter thing in mind, right? So let me quote that example. Tweet can be of different sizes. Now, when Keras is processing it, it is not able to handle a tweet of 50 characters versus a tweet of 15 characters. So to make Kera's life easy, we need to pad each input to make it to a fixed set of characters, right? So we typically don't. So one way to pad it, come up with the padding number is if you take the maximum size of the tweet, then all the tweets will be less than that only. So you can take the maximum size of tweet is 100 characters. So you can say that, okay, I will create a padding thing where every tweet, if it is less than 100, will have extra zeros till it reaches 100. And a tweet which is more than 100, just in case it comes a new tweet, it will be truncated beyond 100, right? So that is what padding means. I hope that
Uh,
satisfies your answer, or you
uh,
have an edge case in
no,
mind.
no, that is near to what I was assuming it. So I mean,
Yeah,
it's same thing.
yeah.
No, how I mean, what does it mean when we talk about images or for any convolutional network? Is it the same thing?
Can you wait for the third class? I have 15 slides on padding and other things. I would jump the gun if I go in here. Please keep your question in mind. Because that's a completely different thing where you have a zero padding towards the end of the image and or towards the boundary of the image, and it helps you save the information which you have in image when you are convoluting it, right? So for a lot of the people in the class, it would not make any sense, but I'll definitely cover it in the third class, the padding thing.
So that's why I say that we can go off record, because I was going through the window sizing, strides and pooling and all, but this padding I could not understand. So
Okay.
thought of asking.
Okay. Okay. Cool. I mean, I would recommend to take it at the same speed as we are going in the class, so it will be easier for me also to kind of handle queries. But yeah, it's good that you are reading ahead. That's good. Padding is not difficult. I would say again, read the same book which I have referred in the morning, right? Deep Learning in Python. That's also applied a lot of. I mean, that's also defined it really nicely, and it's a good book. I'll say for learning. I mean, I would attribute most of my patents which I've got from concepts learned in that book. It is really good. So yeah, you can refer to that book and also ask me in case of any queries. I will definitely cover it in detail in the third session of the class as well. Okay.
Yeah.
So thank you all. We'll meet next week.
Sir,
Yeah, go ahead.
there is a message in the chat box from Venkataramana.
Okay, okay. I did not see it. So in sequential, we cannot do multiple inputs. Yes, Venkatarama, to be okay. In most of the cases in sequential, it's not possible to do this multi-input, multi-output model. So that is the example also I gave where we had different kinds of inputs and then we were taking output. So you are correct. Yes, the answer to that is yes.
Sir, and is there any assignments for the session?
I would not give an assignment for this session. I would probably give a group assignment later on, and I would have a quiz later on in the session. Probably not in the second session, maybe in the third session. So right now, I would just recommend everybody to get access to this book which I have just shared, right? And anyway, you are uploading the first edition. So first edition for basics is fine, and just read through this. That's the assignment. Okay.
Okay, sir. Thank you.
Thank you. Thank you. Bye. Bye all.
Thank you.
Yeah.
Bye.
Thank you, sir. See you all.
Thanks. Bye.